If Docker containers seem way too complicated for you or too complex to just even use them on any kind of application, this is the series for you. Now, me personally, it took me way too long to start using containers, and now that I do, I can't imagine not using containers. It's really just that fundamental. And of course, the question of it itself is it's about packaging your application in a way that's far more portable than other methods. That is any kind of programming language that's out there, Python, Ruby, Node, you name it. It can be packaged up into a container and moved around. Now, me personally, it took me a while to actually start adopting containers because the Docker file was just too complicated for me at the time. But this tool actually changes that. So much about Docker has evolved over the years, and Pack, the tool we're going to be using, is going to use something called a Buildpack to actually make our container application for us. So we don't have to worry about a lot of configuration. We really just have to worry about how do we run our application in production especially, and also what runtime or what version of software are we going to be using, like Python 3.10 or 3.11. Those two things are really all we have to worry about. Pack or Buildpacks will take care of the rest, build our container so we can deploy it anywhere we want. I'm going to show you a really practical example of that in just a moment. And I want to emphasize that the container itself is a lot like running a Python application, but instead of running the Python application, you run a container. It's really, really cool. I'm excited to show you. Let's take a look at the demo. I just wanted to show you a quick demo as to what we'll be doing in this one. The end goal is to have something like this. This is a public static IP address. You probably can't access it now, but it is a public static IP address that has my application running for anyone in the world to go to. It's fantastic. Yes, you could use this to point a custom domain name to, and then you would have, yourdomainname.com going to this IP address. It's really, really cool, and I think it's actually pretty straightforward. Now, how we get here is by using containers and a tool called Buildpacks. But before we talk about any of that, let's take a look at the code itself. First off, the application. This is a Python application. It's a very simple Python application. And I've got this requirements.txt, which actually just shows all the different requirements in here. That is pretty much all I need in conjunction with a thing called a Procfile that basically tells the Buildpack itself to run this command to run my application. That's it. From there, it will actually we'll be able to deploy it right into Docker Hub, creating a container, which is basically a bundled version of our application that will just run wherever containers can run, including Kubernetes. And then once we have it as a container, we define something called a manifest. This manifest references that exact same container and a specific port, and then does some other things as far as labeling it, and then also provisioning a load balancer. This stuff right here, this manifest, is for Kubernetes. Once we actually provision this and get it all up and going, Kubernetes will then run those containers and give us this load balancer, which is fantastic. All of this stuff sounds potentially complicated, but the thing that's missing from all of it is a Docker file. I don't have a single Docker file in here at all. A Docker file actually is what tells Docker how to create a container, how to do something like this. We don't have to use it at all. Instead, we're using an application configuration for that application, so requirements.txt, very standard with Python, a specific runtime version, and then a Procfile. That's it. That's all we need. This Procfile is used in other places as well, but the idea is just simply the command we want this application to run in production. Buildpacks handle everything else. It's really cool, and I'm really excited to show you how to do it. So let's take a look at how to clone this project and get it going. To get started, download the code on GitHub, and that's at Coding for Entrepreneurs GitHub repo. Of course, the whole thing will be linked in the description. You can either download a zip file if you're not familiar with Git, or you could just download Git and use that, which is what I recommend. So to do this, we're going to go ahead and copy the URL. I'm going to navigate in my terminal to a repository where I'll store this, which will be git clone, and I'll just copy that entire thing, and then we'll go ahead and navigate into that folder with cd that. Okay, great. So I'm actually not going to use VS Code just yet. We will use it in a moment, but the idea being is we need to set up our virtual environment. This is actually what Pack or Buildpacks are going to do for us. The same sort of thing. It's going to take our code and just kind of infer the environment that needs to happen. Now, I already know, and maybe some of you already know, with Python projects, they create requirements.txt, which means that I need to use Python. Again, this is what that Buildpack is going to do. So if I do python 3-m venv, this will create a virtual environment that helps isolate this project from other projects on our machine. Then I can activate this with source venv bin/activate. That process is slightly different for Windows users. Next, I can use Python in here without the 3 this time. I can go ahead and do python-m pip install -r requirements.txt. Or I could just also update pip itself, which is what it often will say. So you can use pip directly as well, just like that. Okay, cool. So this means my project is up and working. Now I also have this rav.yaml file. What this shows you is exactly what we just did in some degrees, but it also has a few other extra steps if you were interested in just really building out this environment. But I'm going to go ahead and run this developer or this dev server command here, which is just unicorn or uvicorn rather, source.main app and reload. This will run the Fast API application on this port right here on our local host. And there we go. So we now have our project fully set up. All I'm going to do in just a moment is turn this into a container that can run on Kubernetes. I'll explain all those things in a little bit. But the way we do that is using Buildpacks, and how we're actually going to use the Buildpacks without installing anything. We're going to go ahead and use GitHub Actions. I'm going to assume you've never used GitHub Actions before, so we can see a hint as to why it's so great and why we use it in this project and many projects. So if you go into Actions on any Git repo that you own and click on New Workflow, you'll see something like this. Now, of course, if you didn't see that button of New Workflow, this is what you would see. And so you can actually search for all kinds of pre-existing workflows that you can just use, right? So like I use Django all the time. Here's a Django application. There's a Python application, right? So there's a bunch of stuff for it. And if you noticed, it's suggested for this repo, which means that it'll actually looked at the code and said, hey, these might be some good ones for this Python project. So if you do the Python application, hit configure, what's cool about this is it gives you a bunch of options, pre-filled options as to what you can use with GitHub Actions. Now, I'm not going to go through all of these. The main ones being that, look, you can install a specific version of Python. You can then install the requirements like we did just a moment ago. You can install things for testing, and you can do all of that. And also a requirements.txt file. It's great. So there's a lot of options you can do with GitHub Actions. Now, to me, what it does is it provides a way for me to just run code anytime, just in little chunks. All I have to do is configure the correct environment for it. So what I already did for you was I actually created the initial steps to run this code. And that is using a newer version of Python 3 than that previous example that we saw. And then I installed the application dependencies. So this is everything I just did. Just slightly modified and also used on GitHub Actions. Now I realize there's a number of things like in here that might not be that clear to you just yet, which is why I hope you explore more about GitHub Actions. This is not about that. Instead, what it is about using the cloud native Buildpacks inside of GitHub Actions. Now, once again, you could download and install all of these things on your local machine. They just run more consistently and a lot easier for all of us on GitHub Actions. So we don't have to configure our environment to work perfectly for Buildpack because it requires a number of things, which we'll talk about in just a moment. Now, really quickly, we're just going to go ahead and run our GitHub Actions so you can see what it looks like when one is successful. Before we do, I want to point out that it's really important how we actually have paths for our GitHub Actions. Now, if we see here inside of this repo, I have this .github folder. And of course, I have it open up in a text editor called VS Code right now. But if I look at my terminal and list this out, I actually don't see that by default with the ls command. Now, some machines already show that out, and you can actually do it with ls-al. That will also show that folder. But this folder is really important. This is how we actually have to set it up, along with the workflows folder. Now, all of this would have been done for us if we just used a pre-existing workflow, but I want to show you exactly how to actually run one. You go to Actions, you go to one of the workflows that exists. This value right here is directly correlated to the name that you give it up here, and then I can go ahead and run this workflow right inside of GitHub. The reason I could run this workflow is because of this parameter right here. Now, again, I could go in through all of the depths here, but the idea being that I can predefine all of the things I want to run as jobs, right? So each job runs on an operating system within a Docker container. You don't have to worry about that right now, but the idea being it's isolated from everything else. And then we've got steps that it'll run. It'll do these things in order, of course, like any step should. So the first thing is it actually grabs our code from GitHub. Then it's going to go ahead and set up Python based off of the version that we have. In this case, I have version 3.11, so this should just say 3.11. And then the next thing being that it installs those dependencies for the project. And it took a grand total of 24 seconds, way less time than me to just share you about it. But the idea being is you can come in here, you can look at the job itself, and then you can see what happened in this job. So you can see that it installed everything. So with this in mind, let's actually set this up for using a build pack. One of the things I really like about GitHub Action workflows or GitHub workflows is the ability to use first-party and third-party tools inside of the workflow itself without that much configuration. So for example, the first one that we notice is this right here, this uses and then actions/checkout. This is an example of a first-party plugin that GitHub workflows have. So if we actually just go to github.com/that-actions/checkout and hit enter, what we will see is quite literally the GitHub action that you can use in your project. This is directly from GitHub themselves, right? So GitHub manages this action, and then it even gives you an example of what you could do with it, right? In our case, we just use our default repository, so we don't need all of this configuration. But what we saw as well with our code was setting up Python 3. Again, another first-party tool that GitHub actually allows us to use, and we can set up a specific version of Python in there. And, once again, we can actually take a look at that value under actions/setup Python. Now, the one we need to use is one from Docker, not from GitHub, but a third-party one, which is from Docker, and it's called a login-action. So this login action will allow us to log in to Docker Hub with a token and all of that. So that's actually what I want to configure now. And so if I scroll down here, here's the action. This is all I need. I can copy this quite literally into my workflow here. So I go ahead and bring it in just like that. Now you can separate it and not have anything on here. I like putting the dash right next to name. It's just one of those things about YAML that you just need to learn about. So the other cool thing about GitHub Actions is the ability to hide secrets. No surprise here, we have two secrets that are inside of the login action because we don't want sensitive information to come out. Just like when we installed these pip requirements, we saw all of that data, right? So let's go back into our repo and click on Actions, go into Install App Dependencies. We see all of this being output. We don't want that when we log in or use sensitive data. Of course, GitHub has support for this, and it's really simple. So the first thing is the Docker Hub username. So if you go to hub.docker.com, you're going to want to log in, right? So this might feel a little bit more advanced maybe, but it's not. This is just a place where we're going to store our container. This is where we're going to be putting our application after we configure a number of other things. It's sort of like GitHub, but it's not like GitHub. And we'll see why in just a little bit. But the idea being is we use our app to build a container, and then we deploy that container to a lot of different places, not the code itself, but the container. So at this point, you should log in to Docker Hub with your own account, as well as GitHub. Log into your account there. And if you don't already have this repo on your account, the one we've been working on, make sure it's there because of what we're about to do. So back in Docker Hub, we've got our username here. In my case, it's jmitchell3. So I'm going to jump back into the repo on my account, go into settings. If you aren't on your own account, you won't see settings, right? You'll see something a little bit more like this, not the whole thing, right? Because you don't have permission to adjust the settings on my repo. Anyways, so I go into settings, I navigate down into secrets and variables, I go into actions, and we're going to create a new repository secret. Now we already have what these values need to be. Docker Hub username, which is jmitchell3 in this case, or your username. We're going to go ahead and add that one. The next one is Docker Hub token. I'm going to add that one. Now I need to create a token. Definitely do not use your Docker Hub password. Creating a token is way too easy to use your own password. So back in Docker Hub, we just go into account settings, we navigate down into security, we click on new access token, and then you can just name it whatever you'd like. In this case, I'll call it my Buildpack workshop. Now, my permissions that I need are really just read or write. I don't need to delete anything. Especially in GitHub Actions, unless you actually do need to delete previous images or something like that, read or write works just fine. I'm going to go ahead and generate this and copy this token here. And then I'll go ahead and bring it into my GitHub Actions secret. I'll go ahead and add secret. There we go. So at this point, my repo actually does not have the ability to log into Docker Hub yet. So I need to add that. So I'm going to go ahead and do git status. I see that I've changed my workflow here. I'll go ahead and add it, and then I'll do git commit, add a message of added Docker login, and then I have a remote here for that actual GitHub repo, and then I'll go ahead and do git push. So if you don't have those things, you might want to learn more about Git before you get to this point, but that's sort of the basics of being able to update this action itself and all of our code on our repo. And then I'm going to go ahead and run this now. What I'm looking for is a successful response for the login portion, right? If it's not successful, then obviously I did something wrong. And then of course, if you already have all the code, which you might, you can just comment this out with like command / or control /, depending on what system you're on, and just comment out things you don't actually want to run just yet because we haven't configured them, right? So like the Buildpack stuff, maybe you haven't configured that yet. But I just verified in about 20 seconds that I can actually log in to Docker Hub, right? So those things were successful. It succeeded. Now I can actually build my container image and push it to Docker Hub, which we'll do right now. In a moment, we're going to configure Pack, the command line tool to build our containers. But before we do, let's talk about why we even need containers at all. Well, first and foremost, when you think of a Python application, you think of requirements.txt. What this requirements will do is install specific versions on a machine that is running Python. But of course, the question is, what version of Python? I just kind of gave you one. But the thing is, to have a stable application, you need to know what version it's working with, right? Now, maybe it's using Python 2.7, which is a really old version of Python. Maybe it's using the latest cutting edge one. But we can't leave it to maybe. We need to be specific, right? And so, of course, on a lot of these operating systems, we can go to the equivalent of python.org and download the version of Python we might need, right? But this is a little bit cumbersome, especially if we want to release applications with different runtimes all the time, as in not Python, but Node.js or Ruby or whatever. The list goes on, right? And so given that all applications can have so many different backends, so many different runtimes, we need a better way to be able to then put those applications into production. In other words, I need to think of all of the environmental factors on the operating system that I need to make sure my application runs. That's what containers do. Containers help isolate everything so that if the container can run, then it most likely will run anywhere containers can run without additional configuration. So there's a lot we can talk about that, but what I want to do is use Pack, because what Pack will do is create a container for us without needing to know how to do all of the creation of containers. It will infer a lot of the things for us. Now, Pack uses a build pack. It's a little confusing in terms of the names themselves, but Pack is the command line tool that will use another tool that can actually infer what's going on with our code, right? So we can infer what's going on because you see requirements.txt. Or maybe you can't. Maybe you've never used Python before and you didn't realize that and you learned it this time. But if you have used Python, you'll be like, oh, I immediately know how to configure this, right? We need our computers to be able to do that. Pack is a way to help with that. So yes, you can install this locally, but it also requires that you install Docker on your local machine, which both things add complexity to getting this up and running, and really whether or not it's even can convince you that Pack is worth using. I think it is, especially for teams that aren't ready to learn all of the nuances of Docker files and all that. So with that in mind, let's go ahead and copy and paste some code. You can do the same. And it's really simple. Okay, so first off, we give it a name of setup pack, and it uses a specific GitHub action like we've seen before. This one comes from Cloud Native Buildpacks, right? So you can look at it specifically. The version might change. It probably will. So if I go to github.com/ that actual location, I should see the setup pack. But in this case, it's not actually showing it to me. So if I go to Buildpacks, what I can see then is instead of the whole thing, let's just go to GitHub Actions. Okay. And so in here, we've got setup pack. And for whatever reason, when you try to go to it directly, you still need the things that are related to the branch. But here's the action itself. This is what we'll actually end up using for the build pack and for pack CLI. And of course, if anything changes, if this moves around, because this is a much more evolving project than the other tools we've been using, if it continues to move around, just be sure to check out Cloud Native's build pack repo, because the version most likely will change. It will get better. And it will most likely, these two steps will probably change a little bit. I don't know when, but it probably will. Okay, so this gives us the pack command line tool right there, and then we could run it in the next line. This is the command line instruction that you can use if you had pack on your own command line tool as well as Docker, right? So in my case, I have both. So I can actually call pack and I can actually run it. Here's all the different commands in there. And Pack does a lot of things beyond what we're doing here. But the next thing is actually declaring a builder. So the actual build pack that you want to use. Again, a lot of the naming sounds like it's the same thing, but think of this as like a template, if you will, to infer what our code is looking at. And the reason I chose this one has to do with the fact that Google has the need to make it really easy to deploy Python applications on all of their different services. So they actually open source their build pack to do so. Now, of course, it's not just Python, but it's all sorts of things that you can end up using these build packs for. To know what it is useful for, what supported languages are in there, you just scroll down a bit here. You've got Python, you got Node, you got Java, Go, Ruby, and a lot of the newer versions of this. But of course, you could always go to older ones and see what's available there. So if you need an older version of Python 3.7 and so on, right? So the thing is, though, I will touch on these different runtimes in a moment as to the limits of using a build pack in just a moment. But let's actually take a look at some additional configurations that you might need for Python itself, right? So in the language-specific configurations, we've got Python here. We also might want to declare a specific Python version, which we'll look at in a moment. The dependencies with pip, again, requirements.txt and the root directory right where I put it for good reason. And then a few other things that you might end up wanting to use. But that's just the general idea here and exactly what we did with building this out. So we specified that build pack here, which, yes, you can make your own build pack. It's a little bit complicated. But I mean, we might as well use other ones as well. I will say that actually doing build packs is something that I think that Heroku is what made popular. You were able to just push your code and they would use a build pack to build your environment and then deploy it. They didn't use containers, but they used it to build out environments. Pack uses it to build out containers. You could probably use it to build out environments too. But anyways, so this will actually create our container. So this is run pack and create container. And this right here is called a container image, which includes our username on Docker Hub and the actual container name that you want to give it. In this case, Buildpacks Flatpak. So this is tagging the container that way. We could also put in something like :latest in here or v1 or so on, right? And so the next thing is we actually just push it into Docker Hub and that's it. So with all this in mind, let's go ahead and add this and git status, git add, git commit, added Buildpack, and then we'll go ahead and push it. Now, in most projects, what you would probably end up doing is changing how this triggers, that it would automatically happen. So if you did pushes branches to the main branch, you can automatically trigger this workflow to run every single time you do a push, which may or may not be what you want to do. I'm going to stick with workflow dispatch right now to just kind of hone in on what we're really trying to do here, which is build that container image. So under actions here, we go into our build pack. I'll go ahead and run this, and this should actually create the container for me and push it into Docker Hub onto my profile, which should change this right here. And after a few minutes, the GitHub Action finishes up, and I can refresh in Docker Hub, and what do you know? There is my container image right there. We'll run this in just a second, but the idea being we want to check inside of our build pack. We can also verify that, what do you know, run pack and create container ended up working. It did all sorts of things related to Docker, related to Pack, the command line tool, related to the Google Builder and all of that. And then we actually pushed it to Docker Hub, which was that last step, and including all tags. So if you did use different tags in there, which was that : whatever, right? So if I did :v1, this would push all of those things in there as well. Okay, so with this in mind, what I want to do is actually on my local computer, I'm going to go ahead and run Docker whole of that container image. Now, I already did some tests in here, so I have some of this already kind of working, but all of it isn't fully working, which is something we'll still figure out. And now if I do Docker run of that container image, I get a mismatch from my machine and the host. The host machine is built on a x86. So I'm on a Mac. I have an ARM M1 Max. So I just have a different processor, but I can still run this, right? So yet another reason to use Pack on GitHub Actions is that it will work on Linux machines by default, unless it's a Linux ARM machine, which we can talk about some other time, or you can let me know in the comments if you want to see something like that. But when I try to run this, I get this module not found error. That's not great. We want to change that. We want it to actually run specifically the way, well, this rab.yaml file has as reference, either the uviacorn command or the prod server, which is gunicorn, which is definitely installed and something we could use as well. So those are two things they would need to solve by using something called a Procfile, which is what we'll add right now. It's not surprising that when we go into production, we need a command to actually run our application. Now, I actually have two commands that we can use. One is uviacorn, which technically could be used in production, but is not made for that. Instead, we use gunicorn with uviacorn. Gunicorn itself is a web server gateway interface, but then it can use uviacorn to allow for the asynchronous support that Fast API has. Now, of course, that's application specific. It's not related to Pack at all or Procfiles, but we just need to know that there's a specific command I want to run. So to do this, I'm going to go ahead and create a Procfile. It's literally Procfile, just like that. And the default process that you'll use is simply web, and then whatever command you want to run. In my case, it's this command right here. Now, there is one key to this command that you need to be aware of, and that's this 8000 here. that is a port value that I am presetting inside of this command, which will come into play in just a little bit. So now that I've got this Procfile, all I need to do is add it to GitHub. So git add, git commit, added Procfile. And then I'll go ahead and push it. Now, while we're talking about the actual application running, the command to run the application, we can also look at something called a runtime. So runtime.txt. Some build packs will run off of runtime.txt. So you can actually do Python. And in my case, I have 3.11.5, I think. So let me just check. I'll go ahead and activate my virtual environment first. And then I'll do Python -- version. And I should see, well, I've got 11.4 on my local environment. 11.5, I think, is the latest one. So I'll just stick that there. Now, some applications can use this, but the build pack that Google Cloud has, the one we've been using, is actually .python/version. And this will just be the actual Python version that we would want. Now, again, going back into the build pack for, from Google Cloud, if we go down to Python, we see that there's this file of Python version, right? So I like to put both of them in here because if I ever need to change my build pack, I know my old runtime is still in there. So we'll go ahead and add this in, and I'll go ahead and say updated runtime. And then we'll go ahead and push it. Now, of course, you yourself could actually change this or play around with it as you see fit. And of course, there is a difference between Python and Node as far as how you configure this for other kinds of applications. So just look at the documentation for that with the build pack you end up using. And of course, if you use the Google one, there's a lot of actually pretty good documentation for it. So with this in mind, I'm going to go ahead and just run this, and I'll just let it build. And so it's going to build, and then I'll be able to come back and run the pull command again. And then I'll actually run the entire thing all over just to make sure that the container is running. Of course, if you don't have Docker, you don't have to worry about pulling it and all that. I just want to verify that it is working before I get into the Kubernetes of it all. All right, the build was successful from GitHub Actions. And of course, I can go into Docker Hub and I should be able to see a recent build here. And I did. Great. Now go into my local project. I will pull this. It's going to download that latest version, and it's going to take not that long because I already have a version running. So this same process will happen when we deploy this in production, right? And so the next thing is I'll just go ahead and run this. I think I have it somewhere in here. So I can go ahead and run this, and this time it shouldn't fail. I should actually be able to run this, and sure enough I am. And it's using Unicorn with that worker like we saw before. I actually will just leave it at that. We now have that container running. We have everything that we needed. As far as the version of Python that was declared, we can go back into our run pack here and just scroll, I think, to like 300 or so, 350. We should see the version itself. So we've got, here we go. So Python runtime here. And then we've got using version from the workspace 3.11.5. Fantastic. So all of those things worked. We've got a Procfile and we have a runtime. So let's go ahead and deploy this thing to a Kubernetes cluster. Now that I have a container and a container working, I can deploy this application to a lot of places, but we're going to deploy it into a Kubernetes cluster that we're going to create in just a moment. Now, Kubernetes itself has a lot of features, a lot of really, really good stuff on it, but the idea being that it can run containers really, really well, and it can load balance incoming requests to multiple versions of our container running. So like in my local development environment, I have my container running, but I don't have multiple instances of it running. And also, if for some reason the container fails, it's not going to necessarily come back up right away, right? So Kubernetes solves that and many other things. So what we want to do is actually just use Kubernetes on GitHub Actions. So to do this, I'm going to be using a managed version from Akamai on their Linode service. Now, Linode itself and Akamai, they did not sponsor this one, but I do a lot of work with them. So I was able to get you a credit of $100. So grab that so you can do all of this stuff for free. And then once you do, you'll log into the console like I'll do right now, and you'll be able to actually provision a Kubernetes cluster. So once you log in, it's going to look like this. You're going to navigate down to Kubernetes here, and then we'll go ahead and create our cluster. In this case, I will just call this my Pack K8s, as in my Pack Kubernetes cluster. And then I'll go ahead and grab a region that's near me or somewhat near me. It actually doesn't matter that much, but ideally it's not on the other side of the world. Okay, so we don't need the control plane unless you want to pay an extra $60 a month. And then we can go to shared CPU. I can go ahead and do the Linode 2 gig, which is a grand total of like $36 a month. It's not that expensive. So I'm going to go ahead and create this cluster now. And so this is going to take a little time for this to end up working correctly, which we'll look at in a moment. But before we do, what I want to have in my cluster is the GitHub Action. So I want to actually bring in the GitHub Action to my project while that's being built. While we could interact with our Kubernetes cluster on a local system using something called kubectl, that takes a bunch of configuration that we're just not going to touch right now. Instead, what we're going to do is create a new workflow, and this will be deploy k8s.yaml, or deploy our actual container, right? And the reason I'm just putting it in order is just to keep it in mind of like, hey, I want to do the build pack first and then to deploy second. And so I'm actually going to go ahead and copy and paste a bunch of stuff. You could do this probably from our repo, and there's also a good chance that you have this file already. But the idea being here is we're going to deploy it to Kubernetes. This is doing several things here. This is not a service count, but rather deploy a container and container. That's going to be our job, or rather, let's just call it deploy. Cool. So our job name is deploy. We give it a name of deploy container, and then we check out the repo. We set up kubectl. Then we bring in our actual configuration, which we still need to get, but our configuration from our managed Kubernetes service. In this case, it's Akamai Linode's Kubernetes engine, but it could be pretty much any Kubernetes configuration. This is called a service count. This is like a permission, and it's passwords, basically. It's essentially a password to be able to do all sorts of stuff. Next, we're going to go ahead and create a folder called DevOps, which we haven't done yet, of course. Then we're going to go ahead and actually do our deployments and create our service. So before I do that, though, I'm going to go ahead and run and do git status, git add, git commit, and added K8's workflow. And then we'll go ahead and push that. Okay. So the first thing I need to do is I need to actually create a DevOps folder. So we'll go ahead and do DevOps. You can call this whatever you want, but in the actual workflow, I called it DevOps. Inside of here, we're going to create something called a manifest. So manifest.yaml. Now, it is another YAML file, so it might get confused with these workflow files, but it's not. The actual organization of it is quite a bit different. So what is it that I'm trying to do here? Well, in terms of Kubernetes, I am creating something called a deployment. What a deployment will do is it'll give us the ability to have a certain number of replicas running. Another term for replica would be pod. Another term for pod would be container. So if you want to have 3 versions of your container running at any given time, Kubernetes can make that happen using a deployment. With this, we can actually tag these containers a certain way. In my case, I'm going to tag them with the selector of app being Fasti API. Okay, so there's a lot of nuance to this that I just don't have time to cover right now, but that's the actual selector I want to use. And then the template, if you will, I'm going to use, or the design for this container is going to be this. It's not really that complicated at this point. It might be still to you if you've never used containers before, if you've never used Kubernetes before especially. But overall, learning about these things is, I think, very achievable, especially given that this should look a little familiar to you in terms of the actual name that we gave our container with our build pack. That's this right here. It's the same exact thing. The next thing that hopefully is familiar is this container port from our Procfile, which is this right here. What do you know? Cool. So what this is going to do is it's going to give us 3 containers running because of this number. All of those containers are going to be this, and then it sort of expects to run at this port. Now, if I want this to be load balanced, if I want to be able to access it on the internet, I create something called a service. I give it a name that I decide. I specify the type of load balancer. I use that same selector label that I used up here, right? That same one will then route traffic accordingly. We've got this target port of 8,000. That's going to be that same container port that's inside of our Procfile. All of that stuff's the same. And then finally, our port of 80 is the standard HTTP port. So like if you get an IP address, it will be something like IP address and then port 80. That's the standard. We'll see that in just a moment. So this is our manifest. This will actually deploy our container into a Kubernetes cluster using this deploy YAML file here. And then we have to get that secret in there. Now I'll do this part. I'll actually run this workflow in the next part. But the idea is this is how simple Kubernetes can be, right? Yes, there's still a lot more complicated things that go on in terms of getting this thing working and getting it working correctly. A bunch of stuff that I cover in a lot of places, including my book, which you can see in the description. But the idea being that all of this is achievable. You could totally do this without actually ever writing a Docker file, which I think is pretty cool. Let me just prove that to you in the next one. Now it's time to actually deploy our app as a container to Kubernetes. So let's just verify a few things related to that. First off, we've got our code. That code can exist on GitHub or not. We used it on GitHub so that our workflow, our Buildpack workflow, could actually create that container for us and then push it to Docker Hub. Docker Hub hosts that container for us. Remember, the container is just a runnable application of ours with an environment set up. So with this container, I can then deploy it into Kubernetes. The way we deploy it to Kubernetes is by using something called a manifest. This manifest describes what we want Kubernetes to do with all of the various resources Kubernetes has. Now, I defined a deployment so that I can have 3 versions of my container running, which is defined here, and the container itself is defined there. We've got the correct port in multiple places. The service, the actual way I'm going to be able to expose this to the internet, is targeting the same container port as well as the same app labels from the selector. And then I also have a way to then actually deploy these values onto Kubernetes using a kubeconfig file, which we need from our managed Kubernetes cluster. And then I'll go ahead and deploy and run a few commands related to the Kubernetes command line tool, which is called kubectl or kubectl, as some people call it. Okay, so we need to actually set up our repo to have this service count or this kubeconfig itself. So what we're going to do is go into our repo, go into our settings, navigate down into our secrets and variables, into actions, new secret, add the secret in. Now, where's this value coming from? Well, again, we have a managed Kubernetes instance. This is coming directly from Linode in this case. But wherever you get your kubeconfig, you just need to grab whatever that value is, which in this case is in my Kubernetes cluster. So if I go into Kubernetes, navigate into where my cluster is, the managed Kubernetes services will always have a kubeconfig file somewhere. This will give me permission to actually do things in this Kubernetes instance. So I'm going to grab this value and I'm going to bring it into my GitHub Action secret. Notice that it has a bunch of secret values in here. You do not want to share this with anyone, right? Because it will unleash value to actually mess up things in your Kubernetes cluster. Once you have that, then you can actually run that workflow that we have. By far, it's the most basic workflow there is, but of course, we can run it, we can modify it, we can do a lot of things with this workflow that are just sort of outside the scope of what we're trying to do here. And so this is going to now deploy that container to Kubernetes using kubectl with all the commands that are in there. Now, what is happening on the Kubernetes side is we have 3 virtual machines in here that were provisioned for us from Linode in this case. Kubernetes is also being managed by Linode. Kubernetes itself will then distribute the different applications to these different virtual machines and run them effectively and efficiently. And we can do it many, many, many different times, right? So that means I can have other containers running on this cluster as well. I don't need to provision a new cluster every time I want to deploy something, but rather I need to have a big enough cluster that can actually run more applications. So in other words, you can actually deploy other manifests in here. So if you came in and did a manifest, let's say dose or something like that, you could then come in here and also deploy another version of it, which I'm not going to do, but you can. That's the point. You would have to change a few things, which is outside the scope of this one. But let's go ahead and add in our DevOps folder, added K8s manifest, and then we'll go ahead and push it. All right. So one of the reasons that you might want to learn more about Kubernetes is to have the ability to just deploy all kinds of containers all of the time and have them be able to talk to each other and do all sorts of cool stuff. So since I didn't actually have this manifest on here, my deploy to container or to Kubernetes workflow just wouldn't work, right? That sort of makes sense. So let's go ahead and run this again. Now that the DevOps folder is in there, this time it should actually deploy all of my Kubernetes related things. And so that might take a moment. But while that's happening, what I can also do is I can jump into the Kubernetes engine on Linode, jump into my actual cluster, and I can actually go to this Kubernetes dashboard right here. So go ahead and open that up. And I'll also download the kube config file instead of just view it. So downloading it, and then back into the dashboard itself, I can click on this kube config, I can go to it, and then I can sign in. So this actually gives me just a general idea of what's going on in my Kubernetes cluster, right? It's not necessarily the best way to manage Kubernetes, in my opinion, but you totally can do it in here. And you can also upload your manifests right here. But doing it directly in this dashboard means that, well, if you make a mistake or you need to make a change, maybe it's working, maybe it's not. But the reason I did this dashboard here was to then also look at the deployment and service that we have, right? So just kind of give you a basic overview of those things inside of Kubernetes. But what happened is everything worked, right? And so if I go to git echo git pods, I can see that its container is creating, these pods are starting to work. I can see the deployments themselves, not quite ready yet because it happened like 2 seconds prior to this. And then I also see this thing called echo service, which will give me an external IP address, which right now is currently pending. So back in that Kubernetes dashboard, if I go to service and go to services, I can see there's my deployment LB. And if I go on here, I can see there's a cluster IP. That is not the external IP itself, but rather just the cluster one. So we need the actual cluster IP in here, which is not showing up in this case. So let's go into our ingresses, nothing to display here. Our deployments, nothing to display here. There's another reason why I'm like, this is not a great way to sort of manage Kubernetes itself. So what I'll do then is instead of trying to figure out the dashboard, we will come back in here and I'm going to run this workflow one more time because it will actually show me the latest iteration of that service, which would give us that IP address. Again, I don't expect you to fully know this stuff, but we will see this in just a minute as far as the IP address is concerned. Now, there is one more place that we will be able to see for this IP address, but here we go. We've got our echo service in here, and there is my external IP address that I'll be able to access through the internet, hit enter, and there's my hello world. That is my application running, and it's running on Kubernetes. Congratulations, you have just deployed your first container to Kubernetes, potentially. Now, the other place that this will be located is inside of the cluster or inside of the Akamai cloud itself, and going into node balancers, there's that same IP address. In my case, I only have one. You might have more. I don't know. But that is the same exact IP address. And then, of course, using the kubectl command of git service, assuming that you have the correct, kube config file set up, that will also give you this external IP address. Now, for those of you who know IP addresses well, you can use an address record or an A record to put a domain name directly to this, and then boom, you have your custom domain going on here. Granted, there are other configurations to make it secure and all that. That's outside the scope of this one. But what we got now is we went from pack, just building our container, which was like a small portion of this, to fully deploying on Kubernetes, which I think is pretty cool. Hey, thanks so much for watching. Hopefully you got a lot out of this. And more importantly, hopefully you start using containers now. Once you use it a few times, you might get hooked and really want to learn a lot more about containers themselves and designing the container from scratch, using all the configuration to do so. Now, I'll have a lot of resources in the description, so be sure to check that out as your next steps of the next videos you might end up watching. Thanks again for watching. Look forward to seeing you next time.